Hi, in this video we'll learn how to solve the exponential equations. These are the exponential equations and we need to solve them for x. We have to simplify. Okay, so before starting to solve these equations, I want to show you an important property which we will use to solve these equations, and that property is called one-on-one property. It says that when you have the same basis on each side, the exponents are equal. So let's take a look at this example here. Suppose if I have this 5 squared is equal to 5 to the power x. Now what will make this equation true? What will make this equation true? What value of x will make this equation true? The only value which will make this equation true is x should be 2. Because if x is 2, 5 squared is equal to 5 squared. So x should be 2. Now what do you see here? That when I have the same basis, when I have the like basis on each side, the exponents are equal. You see that the bases just go away because they are like. So when you have like bases, they just go away, or you can cancel them out and you bring down the exponents. So the exponents are equal. The same property we'll use to solve these examples. So our main aim is because we have the variables in the place of exponents. So how will we solve? We need to bring them down. So to bring them down, we need to cancel the same basis. We need same basis to cancel them out. So we'll try to convert all of them to the same base. So here I have 16 to the power x is equal to 1/2. So I can write 16 to the power x. Now, how do I write so this will be just 1/2. How do I write 16 in terms of 2? How do I write 16 in terms of 2? So I can write 16 as 2 to the power 4. And then I have x with it, so I will write x. Or I can write that 16 as 2 to the power 4, the whole raised to the power x. Did I change anything? No. I can write 16 as 2 to the power. I just rewrote 16 as 2 to the power 4, so I didn't change anything. And then I have this whole raised to the power x. This is equal to 1/2. Now, we know this property of exponent. We have learned that when a raised to the power m, the whole raised to the power n is equal to a to the power m times n. So whenever you have a power raised to another power, you can just multiply those exponents. So we will multiply these two exponents. So I have 2, 4 times x is going to be just 4x. Now, what do I do to bring 2 up? Bring 2 on the numerator. I can rewrite 1/2 as 2 to the power 1. Now, which property did we use in this case? So there's another law of exponent which says that 1 over a to the power negative m. If you have this thing, then you can make it a to the power m. Or you can also write this as when you have a to the power negative m, you can write that as 1 over a to the power m. So when you have a negative power, you can just write the reciprocal of it. So the same thing we did here. This was 1/2, and since I want to bring 2 up, I can write 2 as 2 to the power negative 1. Now, you see that I have the same basis here. So I have same basis. So using one-on-one property, when you have the like basis on each side, then the exponents are just equal. So the exponents will be equal. 4x is equal to -1. And since I have to solve this for x, I can divide both sides by 4. Dividing both sides by 4, 4 and 4 will cancel out each other. I'm left with x on the left-hand side. On the right-hand side, I have -1/4. So the final answer is x is equal to -1/4. Now let's take a look at this example here. I have 25 to the power x. So I will write this as it is. 25 to the power x is equal to 1 over, how do I write 125 in terms of 25? I can write 125 as 25 cubed, because 25 cubes, 25 times 25 times 25 is equal to 125, right? Now, using the same property here, I want to bring 25 in the numerator here. I want to bring 25 here. So I can write this as 25 to the power x is equal to, I can write the reciprocal of this. And then when I do that, I will have to make sure that I write the negative exponent here since I flip it. So this will be 25 to the power -3. Now, again, I have the same basis. I have like basis, so they just go away, or I can cancel them out. And I can bring down the exponents here. So this will be x is equal to -3. Well, this is the final answer. Now let's take a look at this example here. I have 6 to the power 8 minus x is equal to 1 over 216. Now, how do I write 216 in terms of 6? I can write this as 6 cubed. I didn't change anything. 6 cubed is 6 times 6 times 6, which is equal to 216. Now, again, using the same property, I want to bring 6 cubed here in the numerator, so I can write this as 6 to the power 8 minus x is equal to 6 to the power -3. Why did I turn this to negative power? Because I'm flipping the fraction. So when I'm bringing this on top, the exponent becomes negative. So by using this law, 1 over a to the power m, this is just, you can assume that this is a and this is m. Let's say this is 1 over a to the power m. And when I want to bring a in the numerator, I can just flip the fraction and make the exponent negative. So this is a to the power negative m. The same thing I did here. Now I have the like basis. If you had the like basis, then they just go away and you can bring down the exponent. So I have 8 minus x is equal to -3. Now I have to solve this for x. How do I get x by itself? So let's eliminate 8 from the left hand side. So subtracting 8 on both sides. This will cancel out each other. 8, positive 8 and negative 8 will cancel out each other. I have negative x is equal to -3 minus 8 will be -11. Now I want x by itself, but I have negative sign with it, so I can divide both sides by -1 to get rid of the negative sign and get x by itself. So -1 and a negative, since we don't have anything with x, so we can assume that the coefficient of x is -1. So -1 and negative will cancel out each other. And I have x is equal to negative sign and negative sign will cancel out each other. 11 over 1 is going to be 11. So x is equal to 11. That's how you solve exponential equations. That's all for this video. Thank you so much for watching. Please like, comment, and subscribe to my channel. I'll see you in next video.